Hey guys, and welcome back to a new video. And this will be an amazing video because we will build a weather app, a clean code weather app to be specific, because it's so hot right now here in Germany. I'm pretty much melting, and it would be cool to know how hot it actually is. So we're going to build a weather app. Let's see how that looks like. Yeah, pretty much like this. So that's the app. You can see how warm it is here in your area. I'm sure it's even hotter for some of you. And this will automatically fetch your location. So this will just be a weather app for your location. You could also easily extend this with a search, for example, for some locations. You see the current time, you see the current temperature, like what kind of weather it is with a cool icon. You will see like a description of the weather, some pressure, wind speed, humidity, and you get a little forecast for the remaining hours or for all hours of your specific day. But that is really something you could easily extend. You can also extend this, for example, with a forecast for the whole week. This whole app will be based on an API that we will use that does not require any authentication, so you don't need to register or so, which is super cool, especially for a video like this. Then we will use mostly clean architecture. So we will have like presentation, domain, data packages, we will have mappers, we will have you compose, of course, for the UI. And the only thing that differs from clean architecture is that I won't use use cases here in this tutorial format, because I usually think they are way too overkill, especially for an app like this. Usually, I think here for this app, we would actually just call repository functions in our use cases. So I just want to leave away that layer and just, keep the other layers and still apply all the clean code principles, especially when it comes to like how you can fetch the location with clean architecture and following all these abstractions and stuff like that. That is what I want to show you with this video, so definitely watch this till the end. And now it's actually time to show you how we will actually get the data. Here I am in Google Chrome, and that is the API we will use. Open Meteo, it's called. You can check this on open-meteo.com. And here we can see some documentation, which is really easy to use. This is the only endpoint we will actually use. If we copy this, paste it here in a new tab, and press enter, then you can see this is how the data actually looks like. Here in this case, we would get like latitude, longitude. That is also what we need to provide, so our current location. And then we have this hourly block of code here, or block of JSON, which gives us different lists for different types of data. So first of all, each hour of the day, and I think it even does that for multiple days. And then you can see we get the temperature 2 meters. So that means that is the measured temperature 2 meters above the ground level. And that would be like for the first hour of the day, second hour, third hour, and so on. So we get a bunch of data here. And we actually get more data than this if we extend this request with some more parameters, which you can actually find here in this documentation. If we take a look to the hourly parameter definition, those are all the parameters we could actually extend the query with to actually get more data. For example, we also want relative humidity 2 meters above the ground level. So we could simply attach that, separated by a comma. We press enter, and then we also get all these values. So far for the API, we will dive more into this in the video, of course. Next up here, Dribble design. I just got some inspiration from that. It doesn't look exactly like this. Like I don't have these clouds, I don't have the graph and stuff like that, but the app looks very similar to this. So I'll also put a link to this design in this description. And yeah, just to also give you some inspiration how you could extend this. And something I also won't do is this geocoding. So that means that you have latitude and longitude, and you actually find out the name of that location. Like you would also display the city you currently live in. You won't do that because I think you actually need an API key here for the Google geocoding API. And I think for that you need a billing account on the Google Cloud Console. So that would be a little bit too much setup for a tutorial. So I want to keep this as simple as possible and as easy to follow as possible. And then the last thing we actually need before actually diving into coding is that you need the initial source code here from my GitHub repository. And this time it's actually important that you get this really from GitHub and not just copy over dependencies, because there's some more initial setup that I have here. Nothing about how we structure our code and stuff like that, but let me just show you. So you go to the branch here, select initial, and you can simply go to code, either download it as a zip file or directly clone it here in Android Studio. Let me show you that in Android Studio, what belongs to this initial project. Of course, the dependencies, and that is nothing new for you if you watch my project-based videos. We use Dagger Hilt for dependency injection. We use location services to track our own location. And we use retrofit to interact with the API, and of course viewModel Compose to use view models. But other than that, we also just added some colors here. Nothing special, but this is an important file here, this weather type, which is a sealed class, and I really don't want to show this in the video because the way we will actually decide about the description and the icon for a specific type of weather are so-called weather codes. If we scroll completely down, the API will respond with just integer codes, and each integer code corresponds to a specific type of weather. So you can see 53 would be moderate drizzle, 55 would be dense drizzle, light freezing drizzle. So tons of weather types here you could have in your app, and I don't want to write this in the video. So you can just copy this file. It will contain all the different weather types here as a sealed class, so very convenient. And we can then easily use this in the app to parse the weather type the API actually returns for a specific hour. And something I also wanted to include is here in domain util, we have a resource class which I use in all of my projects just to easily distinguish between success and error cases. You will see in this video how this works. Looks complicated, it's super simple. But yeah, you will see how this works if you don't know this class. And if you watch at least one of my project videos, then you will know this class. And of course, last but not least, what's important is that you have all the graphics, like all the vector graphics for the different weather types, which I included here in the drawable folder. So you also want to have that, like this cloud here, like this rainy thunder, for example, which all look quite cool, I think. So yeah, make sure you have these. Feel free to use these in your app. And apart from that, I would say we actually start right into it. And I will also structure this in a way or like explain as if you would have no idea of clean architecture, clean code, why we do things. So I will explain a lot. I want to assume that you know a lot about clean architecture, about how you structure your projects. So so that everybody can actually follow. The first thing I usually do in such projects is that I set up the API. Because without API, we don't get any data, and without any data, we don't have a working app. So where does that API belong? Well, in clean architecture, we have three main layers of our app. We have presentation, which represents the UI of our app. So view models, composables, if you're using Compose, if you use XML, that would be an activity, a fragment or so. Then we have the domain layer, which is the innermost layer, you can say. And that has a purpose to really isolate the core behavior of your app. So it contains the business logic, the business rules, and really should not know anything about other layers, so about presentation or data. So that means in domain, you don't know if you use a room database, if you use a retrofit API, if you use Cato as a network client. You really don't care about that in domain because it should be as isolated as possible. And then we have the data layer, which, well, interacts with data sources like preferences, like a local DB, like an API as we have here. And that is of course where we now also want to put our API, our retrofit interface. So in our root package, I will create that data package. And in that we will have a remote package because our retrofit interface represents our remote data source. And maybe as a little side fact here, if you would have an app with multiple features, a map screen, for example, where you can scroll through different cities and see the weather of these cities, then I would not advise you to have this kind of package structure to just have data, domain, and presentation. Instead, I would have feature packages, and then in each feature package, I would have this package structure. So you just divide every feature by layer. That is a lot more scalable, but for this app here, it's totally fine to do it like this because we just have a single feature and then our rule package kind of serves as this feature package. However, let's dive into remote and we create a class called Weather API. Select interface and let me add that to Git. And in here, all we will really have is one single function, and that will be the function that calls the API endpoint I just showed you in Chrome. We will be using Kotlin coroutines here, so that will be a suspend function, and we call it get weather, for example, or get weather data, for example, could also be a thing. And that now takes two query parameters, because what does the API actually need to know from us? Well, that is of course our location, because otherwise it doesn't know what kind of weather data it should return. And we specify that with query parameters like this. The first one is the latitude, which I will abbreviate with lat, and we will of course also have the longitude like this. Now we need to specify what kind of request that will be. So get, post, put, or whatever. That will be a get request. We're just getting data here, and we need to specify the endpoint, which is a very long one here. So I recommend to copy what I now paste from my GitHub repository from the Weather API interface. So that's just the route we actually access. We make sure we hit the forecast endpoint, and we specify some hard-coded parameters here that are always the same for every request. Like we want hourly weather, we want the temperature in our data set, we want the weather code, which just gives us information about what kind of weather it is, so if it's cloudy, sunny, and stuff like that. We have the humidity, wind speed, and the pressure level. So with that, we just make sure that we get all the data we want and not more. And now that function, of course, needs to return something that we get from the API as a response. And that will be our weather DTO. So in clean architecture, we often deal with these so-called DTOs, data transfer objects. And these are just Kotlin data classes that represent the JSON response we get from the API, nothing more. I'll put this in remote as well. Create a weather DTO here. Select data class. And what will this contain? Here we really only put the information we need in the app, and that is just the hourly field. So if we take a look in the API response, it's really only this field that we are interested in the response. So that is the response here, and this is one field of the response. If we scroll down, we also get things like how long it took the API to generate this, hourly unit, stuff like that. We only want this hourly block. So we put this in the app. In here, I'll call this weather data though, because if we would call it hourly, it wouldn't really represent what this represents. So I will make this a weather data DTO, which we don't have yet. And to make sure that Marshy can actually parse this, so we will use Marshy for JSON parsing here. This actually normally would need to have the same name as the JSON field from our API, which is called hourly. But since that's not the case, we need to annotate this with that field JSON from Marshy here and specify the actual name, which is hourly. And then we now need to create our weather data DTO, which is basically all the stuff we have in this hourly block. Like we have more in our app because we request more parameters. Maybe we should quickly just show you how that would look like with our actual endpoint. Let's see, let's take that and paste it here. Oops. Instead of this. And that of course also now needs the latitude. I'll just pick 53 here. I think that should be fine. And 13 for the longitude. And yeah, there we go. So that is the actual response we will get in the app. If we collapse all these, then you can see we only care about this hourly block here because that contains the weather data, our humidity, our time, pressure, weather code, wind speed, and temperature. So that is what our weather data DTO actually needs to contain. So back in Android Studio, I will just paste this DTO here. You can either get this from my GitHub or just quickly write it off. It's not a lot, but yeah, pretty much we just have the time. That is also called like that on the API. We have our temperature, actually should be plural here because we get multiple ones, temperatures. And the JSON name for that is temperature 2 meters. We have our weather codes. We have our pressure levels, wind speeds, and humidities. So then in Weather API, we want to make sure that we now return such a weather DTO, which contains our weather data DTO. So that should now look fine. Yeah, now it knows that. And we successfully created our API. Now, what is next? The next thing I want to do is I want to create our so-called domain models. That is a core concept of clean architecture, that we have models in our domain layer. And if you remember what I mentioned at the beginning of this video, the domain layer is our innermost layer, and it should not know anything about implementation details. So it should not know if we use retrofit, if we use Cato client, or something similar. And if we would now take our DTO objects, which contain our weather data, and use them in our domain layer, for example, if we need to kind of do something with this data the API returned, then that would be wrong, because these DTO objects contain implementation details. They contain the detail that we actually use Marshy, since we use these annotations here. So what we typically do with clean architecture is that we have so-called mappers on the data level, and these mappers have the responsibility to actually take our DTO objects and map them to objects that lie on the domain layer, which kind of don't have these implementation details like these annotations here. You could also imagine this with room entities. There you would have this entity annotation. So your domain layer shouldn't really know about this, because the reason for this is if at some point you change the implementation details, which in software development can very often happen, so that you decide to use Cato client instead of retrofit, to use another kind of database instead of room, then that would not only change your data layer, but it would also change your domain layer. And your domain layer should be as isolated as possible, so that if something changes in your application, the core foundation and the core logic will stay the same and is not affected by these changes. So if something changes, it should always only change one single layer of your app. And also we typically have domain models that are just objects or classes that are much easier to deal with in code than with our DTOs. Like for example, here the DTO contains the weather codes of type of integers, and we don't always want to have this list of integers to actually check what kind of weather it is. We want to have a more convenient way, and that is why I actually implemented this weather type class, so we can parse the type of the weather once when we map our DTO object to the domain object, and then we can very easily just check, okay, is the current weather maybe clear sky? Is it mainly clear? So we have very readable names then for a specific weather type in our domain model that makes it much easier to actually deal with that. Without further ado, let's actually do that, and then you will understand what I mean if you're new to this. In the weather package, I will create another class called weather info. So just a class that contains information about a weather. And here, this class should now contain the weather data per day, basically. So we want to have an easy way to say, okay, I want to access the weather data for Tuesday, for the next Tuesday. And then we should get a list out of that gives us all the different hours for Tuesday containing the weather information. And for that, a map is pretty good, I think. So let me show you what I mean. We have the weather data per day. And that is a map of type integer to a list of weather data. That is what we need to create. So this map will basically map the current day index to the weather data list of that day. So weather data would represent the temperature for that day, or not for that day, rather just the temperature for a specific hour of that day. Therefore, we have a list to represent all the temperatures for that day. It would also represent the humidity, the pressure, and stuff like that. Basically what we get from our API. So if we would kind of get or access this map at index 0, or at key 0 rather, then we would get weather data about today. if we would access this map with the key 1, we would get weather data about tomorrow, and so on. So we'll basically have 7 entries here in this weather data, because that's how many days the API returns. And we can very easily use this to then display the forecast for the next week. And then we also want to have the current weather data, which is also weather data nullable. So this will just represent the weather data for today. Not only for today, just for the current hour we're actually in. So if we hit the API at 1 p.m., for example, then this will be the weather data that contains the temperature for 1 p.m., the humidity for 1 p.m. So that is of course contained already in this map, but it's a lot more convenient if we actually calculate this once here on our mapper level and then always have this current weather data to deal with. So the next step is to create this weather data domain model object in our weather package as well. By the way, maybe I should mention that as well, why I put that in the weather package. In some videos, I created a separate models package in domain where I put in all of my models, and that's fine for most apps, but I feel like if you separate your packages by context, so by what's inside of that and not by type, like by models, that's a little bit more scalable, I feel like, because if you just see the package type, you know what's in there if you do it by context, like we do it here with weather, and you can give your project some kind of structure. So if you would also have some data-related weather dependencies in the data package, you would also have a weather package there. So it's kind of a consistent structure and I like it. But there is no general right or wrong, I would say. Let's just go in here and have a weather data class. And this will contain some fields about a specific weather data, so specific data for a given hour. On the one hand, we have the time, and I want this to be represented by a local date time object. So there's another reason why we have domain models, to just have more convenient objects to deal with that. Because with a local date time object, we get information about the specific hour, about the specific seconds, without us needing to actually parse a string or so every time we need it, like a time string. And then we have the temperature Celsius in form of a double. We do have the pressure level in form of a double. We do have the wind speed, double. The double. We have the humidity, also double. And we have the weather type, weather type. And such an object is now, of course, a lot more easy to deal with in our code than if we have this object, or actually this one here, which contains lists of doubles, lists of integers, where we would need to parse a lot. So we just take this parsing and do it once in our mapper, and then we can always very easily deal with the actual weather data object, which contains our weather type field class, our local date time, and just the specific values for a given hour. So the next step is to actually create these mappers that will take our DTO objects and map them to our domain level objects. And we will put these in data, because these will of course interact with our DTO objects and therefore need to be allowed to access these, so they can't be on the domain level. So I'll create a package here in data called mappers, and in that we will just have a file called weather mappers. And in that file, we will have extension functions to just map one type of object to another, so our DTO to our domain level objects. The first function I want to have here is actually a function that maps a weather data DTO object to a weather data map. So this map I'm talking about here is actually, where is it? This map here, exactly. So we basically map the number of the day to the list of weather data. So for example, if this key would be 0, then that would refer to today, and this list of weather data would then have 24 entries, so one for each hour, and each entry contains information about temperature, pressure, humidity, all that stuff for that specific hour. Cool. So we're going to return this map here. List of weather data. And that, of course, now returns our domain level object. That's the purpose of this mapper. And this will actually be a little bit more complex, this mapper here, to kind of transform this weather data DTO to this map, but you'll see how this will work. So we will actually start to actually map the time values we get from the weather data DTO, which is just a list of time strings. So if we take a look here, that would be such a string. So we now loop over this list and map this. So map index, we actually need the index. And we map this to weather data objects. That's not so difficult yet, since we can simply get all the different values using the index. So we can say temperature would be, let's call it temperature, is temperatures. At the index of index, we would have the weather code. We have the wind speed. Whoops. Wind speed? No. Didn't I include wind speed here? I did. So why? Oh, it's the variable name. Forget what I just said. The wind speed is, of course, equal to wind speeds at index. And then we will have the pressure. And finally, the humidity. So now we have just references to the single values. Since all these lists have the same length, we can simply use the same index for these. And then we map this to a weather data object. The time will actually now be parsed with a local date time. With that class, we can say local datetime.parse. And we simply pass the text, so this, the time string we want to parse, which is just time, and a formatter that we need to specify to tell it in which format our time is, which is just the standard ISO format. So we can say date time formatter, ISO date time. And that'll then give us a lot more information about that time. We then have our temperature Celsius, we have our pressure, wind speed, humidity, and finally the weather type, which we actually need to retrieve from this weather type class. Here I have this from WMO function. WMO is just the abbreviation for these types of weather codes. That's how these are called. And yeah, that's pretty much also a mapper class. So we can just take this and call weather type .from WMO, and we pass our weather code. So now we essentially mapped our time values to weather data objects. So we now have a list of weather data here. We don't have that in form of a map yet that actually maps the day to the weather data lists. How can we do that? And that's actually where the tricky part starts, because what we could of course do is we could say group by, which actually returns such a map of any type and maps it to values of type list of weather data. And we could say it dot time dot day of month, for example. Then the error would go away, and then we would have a map where it maps the day of the month to this list of weather data. So today is June 26th, and that would mean that in this map, if we access the key 26, then it would give us the list of weather data, so all the different temperatures for today, for every single hour. However, that makes it a little bit difficult later on to actually deal with that, because we always need to find out what the current day is to kind of say, okay, I want the weather data for this day, I want the weather data for in 5 days, then you would need to say current day plus 5 to actually get that corresponding weather data. And it would be much easier to actually have a map that just has 7 keys starting from 0 to 6, and 0 would just correspond to today, 1 would correspond to tomorrow, 2 would correspond to the day after tomorrow, and so on. So that would be a lot easier to deal with because we don't need any information about the time later on. However, if we want it in that format, it makes it more difficult to actually parse it to that, since as soon as we actually have a map, we can't easily map the keys of that map to its indices, because a map doesn't really have indices like a list does. So we can't simply say that a map keys we simply map all keys and then say just to like it.index or so. That doesn't work. And there's no map keys index function because a map does not have indices. So how can we do that instead? We can actually calculate the information we want using the index we have here. So that index will range from 0 to a very large number, which is pretty much 7 times 24, because we have 24 hours a day and we have 7 days in that big list the API returns here. So we have 24 strings here per day. You can see over that 26th. And for each hour we have a string, and then it goes on to the next day and so on. So there are 7 times 24 entries in there. And with that information, we can actually calculate what we need. And what I will do is I will create a little data class here that assists us, which I will call indexed weather data, which will kind of serve as a temporary class here that's just used to forward this index parameter. So that will be the index, and we will have the actual data that we also, of course, need to forward. I think we should be able to make this a private one. Yeah, because we only need this in this file here. So then we want to go here and not only return this weather data, instead we want to cut this, map this to an indexed weather data, where the index is just the current index here, and the data is what we just copied, or rather cut. Then we want to go to group by, and we group this by it.index divided by 24, because we have 24 hours a day, and we always round down. So if we are at day number 1 in our list, let's say we would have this entry here, which corresponds to the 26th and the 3rd hour of that day. And it would be the third index in that list. So 0, 1, 2, 3. Then we would take this index, which is 3, and divide it by 24, which is 0. So it corresponds to the 0th day in this week, you can say. Let's say we would be at day number 2. Here, the 27th actually starts. This would be at index 24. So we would take this index 24 divided by 24, which is 1. So this now corresponds to day 1. And that is how this basically works. So now we have the map of integers to indexed weather data, but we actually want a map with integer keys to list of weather data. So we don't care about this indexed weather data. So what we still need to do is we need to map this again. And this time we need to map the values, which are indexed weather data, and we want to map these to normal weather data. So map values, and we map this to, well, it.value, which represents to this list of indexed weather data. And since we want to map the items of that list here, the indexed weather data, we need to say map again. So I know that's quite confusing. We just say it.data, which refers to, where is it? Here. It just refers to the weather data this indexed weather data holds. So I know this was a kind of confusing function here with this end. I would suggest you to just play around with that a bit if that is confusing for you. So you could just say something like also, and just print this, or just print the keys here, for example, print the values. So you see what this group by function actually does. However, the next mapper function we will have here is a bit easier. We can just say weather DTO, so that will map a weather DTO to a weather info object, return a weather info object. And what does such a weather info object contain? Well, it contains our weather data per day, which is exactly the map we are now able to calculate or now able to generate with our previous function, and the current weather data. So we kind of need to process the corresponding weather data for the current hour of the day. First of all, I want to say weather data map is equal to weather data dot to weather data map. And then to calculate this current weather data object, we want to have a reference to the current time, which is local datetime.now. And then we can say, well, current weather data is equal to weather data map, which contains that at the index of 0. So that corresponds to the current day. And now we need to find the current hour in that current day. So that if we access this at a specific key, that would return a list of weather data now. So we could say .find. So we, in that list, which contains all the different data objects for each hour, we want to find the right hour. So the hour that is the closest to our current hour, which is contained in this now object. So we can say val hour is equal to if now dot minute is actually less than 30. In that case, we want to kind of round down. Then we say now that hour, and else we say now that hour plus 1. So if we are, let's say, at 1 p.m. 20 minutes, then the minute would be less than 30. So we would get the weather data for 1 p.m. If we would be at 1 p.m. 50, for example, then the minute would be larger than 30. So we would actually take 2 p.m. as the time, since that's closer to our current time. And then we just want to find the object where weather data, or where it dot time dot hour is actually equal to that hour. And then all we need to do is we need to return that weather info object. Weather data per day is weather data map, and the current weather data is current weather data. And again, this map won't actually be that much used in this tutorial, since we just get the weather data for the current day. So we could also make this a lot more simple, but since we get this data already from the API, and I want to give you also a little homework to extend this with a forecast for the whole week, I wanted to at least have a decent data structure to easily extend this app here with more days. So what is the next thing we want to do here? The next thing is to create the repository. The repository's job is to just kind of combine the different data sources we have. We only have one here, which is the API. But if you would, for example, have a local database cache, then the repository's job would be to kind of get data from the API, put it in the local cache, return data from the local cache, and things like that. I just like to have it as a design pattern for data-related stuff. The repository should always be abstracted out with an interface, which we put in domain, since then the view model, which we later have, can actually access that repository from the domain layer, since it shouldn't directly interact with data. Let's do that here in a repository package. And we create a weather repository interface. And the reason why you should always abstract out your classes, so when I say abstract out, then I mean to create an interface or an abstract class for your classes. The reason is just that it's a lot easier to later on swap out implementation details, as I mentioned. So if we later decide to use a different type of API library, for example, like swap out retrofit with Kato client, then all we would really need to do is to change the implementation of the weather repository, but not this interface, and also not all classes that depend on this interface. And that also makes things like testing a lot easier actually, but that would be a little bit too much here for this course. So here we will simply have a suspend function, get weather data that will take the latitude and the longitude, and then return a resource of type weather info. And here now this resource class comes into play, which we will use to easily just forward the status or the result from the API to our next layer, which is in this case the view model. So if the API returned a successful response, we just simply return this value with the data the API returned. And if there was an error, like we don't have internet connection, we return this instead with a given error message that we can also then extract in the view model. It's a pretty cool class. So then we go to data, create a repository package. That's now where the implementation of this repository goes. And we have a weather repository implementation, which will implement this interface, weather repository. We want to have our get weather data function, and we need access to our API. So private val API is our weather API. And I want to inject the constructor here using Dagger Hilt, so I say inject constructor, and then Dagger Hilt will automatically be able to create this type of instance for our repository if it knows how to get this API, which we'll do later. And I'll also explain a little bit about Dagger Hilt. And this function is super simple. All we want to do is we're going to return try catch. So if something goes wrong, we will catch an exception. I won't do any fancy error handling here dependent on different exceptions. I will simply print the stack trace and then return a resource that error with e.message. And if that's null, we want to say an unknown error occurred. And then in here, we want to return a resource that's success, where the data is actually API get weather data, let is let, long is long. And then we take this result and we can now map it. So we can say to weather info. And there we go. And if something goes wrong here with this API call, we will jump into the catch block, return an error message. And if not, we will just return this resource success with the given data we got mapped to our weather info object. So what is next? Next up, we want to worry about location tracking, because that is also data related. It's also kind of a data source to get a location from your GPS or so. So what we will do is we will again have the abstraction, which will be a location tracker interface. Let's create that here in domain in a location package. And that's also what I mean with these context-based packages, because if your package is called location, and then you'll also have a location package in data, then you know these are closely related. And it's likely that in the domain location package, you will have a bunch of abstractions, and on the data location package, you will have implementations. You'll see how this will work. In here, we will simply have a location tracker interface. And well, what do we want from a location tracker, like from any kind of location tracker, no matter how that's implemented? Well, we want to have a function that just gives us the current location. And that will be a suspend function, since that can take a moment to actually retrieve the location. And I want to use coroutines here, and that will be called getCurrentLocation. And return a location here. A nullable one actually, since it could potentially not exist. Let's say we don't have location permissions, or we haven't the GPS one enabled the setting for that. And if you would want to super strictly stick to clean architecture here, you would also create your own location data class that just represents latitude and longitude and return that here. Since that location class, as you can see, is part of the Android framework, we the domain layer shouldn't know too much about the Android framework. But here in this case, since we're just building a pure Android app where we don't want to reuse anything from domain or so, it's fine. But let's say you would want to use a KMM project, Kotlin multi-platform, then you want to reuse this location tracker interface between Android and iOS. You couldn't do this because you would couple this to the Android framework. But for the sake of simplicity, I'll leave it here, just to prevent that there will be some angry comments. Let's go to data, also create the location package here. And in that, we will now have our default location tracker, which we will use in our app. Site class, and make that implement our location tracker interface. What kind of dependencies does that now need? Well, on the one hand, it needs the location client, which actually also comes from the Android framework. Here, it's now fully okay to use this because it's an implementation detail here, like a specific implementation of this interface. And we can retrieve the location with a so-called fused location provider client. Super simple word. Let's provide that here. Private val location client is a fused location provider client. That comes from a dependency we included. And we also need the context actually to be able to check for permissions. So we can simply inject our application instance here. I also want to inject these dependencies here in the constructor. So I'll use this again. And then we can actually override getCurrentLocation. Cool. So two things here. On the one hand, how do we get location? And on the other hand, how the heck do we do that with coroutines? Because the fused location provider client doesn't offer us a function that actually makes a coroutine wait until we got the location. Let's first of all do the simple stuff, and that is checking for permissions. So when it comes to location, there are two permissions we usually need. On the one hand, coarse location and access fine location. So that is just for the for rough location. That is for more detailed location. And internet is actually also sometimes needed, since it sometimes uses the network provider to get the location to make it faster. So we want to check, has access find location permission is equal to context compat dot check self permission. Here we pass our application for the context, and the permission we want to check for is a manifest from Android permission access find location. And if that's equal to package manager permission granted, we know we have that. And now we do the same for access course location. Here we say access course location, and that's it. We also want to check if GPS is enabled. Otherwise, this also won't work. So, is GPS enabled? Well, let's actually not start with that. Let's first of all get a reference to the location manager, which comes from the Android framework. So it's a system service. We can say application, get system service, context location service, and we cast that as a location manager like this. And then we can say, well, is GPS enabled? Is location manager that is provider enabled? We want to check for the location manager network provider. So that would be the provider that retrieves the location using the network, or location manager is provider enabled GPS provider. So if either of these is enabled, we know we can retrieve the location. So we can check if we don't have the course location permission, or we don't have the find location permission, or we don't have GPS. Then we want to just return null, because then we don't have a location. And if you would want to handle these errors more specifically, like to also tell the user what is wrong here, you could wrap this location into such a resource object we have here, and then also pass a specific error message. I'll leave that out here. And now if we have permission, we will actually reach this point here. And then we still need to retrieve the location, of course, in a suspending way. How do we do that? And the answer is we will use a so-called suspending coroutine. So we can say we return a suspend cancelable coroutine, which will give us a so-called continuation. So we can kind of use this to convert a callback to a suspending coroutine. And let me first of all write this, and then I will explain how this works. So we can retrieve the location using our client, get the last location, and we can say apply. You can see this returns a task. So this does not give us the location yet, since that's an asynchronous thing that takes a moment. Instead, it gives us a task, which we can then use to either listen for a successful result, for an error, or maybe if it got canceled. So first of all, I want to check if the task is already complete. So maybe there is already a last location that is known, then we don't even need to wait for that. If that's the case, we can use our continuation, it's called like that, to be able to continue with something. So we can just continue with the coroutine in which we execute this suspending function here. And we can say we resume. And we need to resume with a specific result, which is our location. So we just return with the result which we get from our task. And else, or actually, we need to do one more thing. And that is we also want to check, in this case, if the task was actually successful. Because being complete doesn't yet mean that it is successful. It could also be a failed task. So if it failed, we want to resume with a null location. And we still get an error here. I don't know why. Okay, it's experimental. Let's add this annotation to our default location tracker. And why is it? Feels like I'm using the wrong resume function here. Resume, I just want this with a single location. And here we pass the result. Yeah, then it works. And then we can actually get rid of this else block and just make sure we return here in case we already resumed, because if you resume twice, it will actually crash. But if it was not complete, we actually want to wait until it is completed. And that's where the async stuff actually starts. So we can say we add an on success listener here to this task, which gives us the location here in this callback. And then we can say cont.resume with it here, once that was successful. But in case there's an error, we can say on error or on failure listener. And we can say can't resume with a null in this case, so then we don't have a location. Or if this actually was cancelled, we want to say can't.cancel, so we also make our coroutine cancelable here in this case. And that's pretty much how we can transform a callback, like these callbacks, to a coroutine. So it's now very easy for us to actually just call this function and block a coroutine until we get the location and then resume that coroutine. I love to do that. And that's already it now for our data layer, I would say. The next step would be to actually set up Dagger Hilt, which will be used for dependency injection. I won't dive too deep into dependency injection. I just released a very, very detailed course about Dagger Hilt, which I will link somewhere up here. So if you have no idea about that, then I would highly advise to watch that course. I will explain a little bit, but not every single detail. So I kind of assume that you have worked with that before or watched that course. So I want to start to actually create the Dagger modules in which we just provide our dependencies to be able to be injected. And I'll do that in a DI package, which I will set up in the root package. So dependency injection, and create an app module object in there. So in here we just tell Dagger Hilt, this is how we can create our retrofit interface, this is how we can create our location tracker and things like that. Needs to be annotated with module and install in. So we want all these dependencies to be singletons, so we say singleton component. And then we can start with our retrofit interface, annotate it with provides and singleton, and we say provide weather API. That will return a weather API instance, and in here we now need to kind of create that and therefore tell Dagger Hilt, hey, that's how we can create this instance. So you want to say return retrofit.builder. We want to specify a base URL, of course, so the URL of our API, which is https API open-meteo.com. And then we want to add a converter factory to automatically parse JSON to our Kotlin data classes, so to the DTO objects. Here I will use the Marshy converter factory.create, and then we can say that build.create, like this. And there we go. We just created our API interface. Very easy with retrofit. What is next? We actually also need to provide the fused location provider client, which we inject here. So we go here, provides and singleton provide fused location provider client. That will need the application instance to be created, so we can simply use that here and return a fused location provider client. Return location services, that is dot get fused location provider client with our application instance. Very easy. And then what we also need to provide is, on the one hand, our location tracker and our weather repository. And I like to do that in separate modules, since both of these are abstractions, so interfaces. And with Dagger Hilt, we can use a different kind of syntax to actually provide abstractions, which just generates a little bit less code. So in DI, I want to have a location module. Will be an abstract class module install in singleton component. And the difference here in terms of syntax is that we use binds instead of provides. Still a singleton, and we now make this an abstract function, so we don't need to kind of write code to provide this instance. And we say bind location tracker. And we specifically want to bind a specific instance, which is a default location tracker. But we want to actually provide that as the interface. And here we can actually also add this annotation to location module. Just like that. So whenever we inject a location tracker, it will actually use an instance of default location tracker. And that only works if we actually have an inject constructor here for that, and that only works if Dagger knows how to create these instances. That one we actually provided with a provides function, so that works, and it's able by default to actually inject the application instance. So we're gonna have the same type of module for our repository. So I'll just copy paste the location one, call it repository module. And here we want to bind our weather repository. So here we now specify the specific implementation we want to bind, which is just the only one we have. And here we specify the abstraction, like this. Cool, so I think that's it for the modules. The next step with Dagger Hilt is that we need to set up our application class, which is super easy. In our root package, we create our weather app, make that inherit from application, and all we need to do is we need to annotate this with Hilt Android app. So just that it knows where to get this application context from. Cool. Then we go to manifest, actually add this application class here as a name, weather app, and that's it for Hilt. We are now able to inject dependencies. What is then next? The next step would be the view model. What's now the purpose of the view model in clean architecture? Well, the purpose is that it kind of interacts with the domain layer. So in our case, for example, with our location tracker, with our repository, and it actually calls the functions of these instances and takes the result, so what we get from the API, for example, or what kind of location we get, and it maps that to state. So it maps that to something that we want to then show in the UI. So the UI, in terms of composables or fragments or so, should usually be as dumb as possible. So it should not do any fancy like state parsing or so, at least in my opinion. That is kind of UI logic, and you can do that in the UI level as well, like in composables or so, but that's not what I recommend. But in my opinion, we have view models in clean architecture to do that job for us. So the UI really just needs to assign values from state to UI components, which is then super dumb. So it doesn't really know where these values come from. So in presentation, that is where the view model belongs. We will actually create, first of all, the state that will represent our screen state. So we will have a weather state, that's how I will call it. Select data class, and we will have the current weather info here, of course, which is nullable null by default, which we still need to retrieve. We will actually have an isLoading boolean, so we can show progress bar, and we'll have an error string, which is also null by default. And then we can have a view model in presentation, weather view model, create that, make it a Hilt view model, so we can easily inject dependencies in this view model. And we say add inject constructor. What do we need in this view model? We need our repository in form of a weather repository, and we need our location tracker. Like this. Make this inherit from a view model. Oh, not that one. View model. Cool. And the first thing we want to do is we want to create an instance for our state. So we will have a var state by mutable state of type weather state. Import this twice, pressing Alt plus Enter, and make this a private set, so only the view model can change the state. And then what we'll have is we'll have a function load weather info, and this function will basically call our API, and it will get the location and combine these to a state. That's the purpose of the view model here in clean architecture, just to call the interfaces from the domain layer, or just some classes from the domain layer, doesn't need to be interfaces, and take the results and map them to our state. That needs to happen in a coroutine view model scope.launch. First of all, we make sure that we set the state to state.copy, and we want to start to show the loading value, and we want to reset the error. So we need to use copy here to be able to change the state to a new value. So we just copy it and change these values here. So it's actually updated in the compose UI, and then we can start to retrieve the location. So location tracker, get current location, and if that location is not null, so if we actually got a location, we're going to use that here to actually make the request to our API using the location. So we can say when val result is equal to repository get weather data location.latitude, location.longitude. And when that is a resource success, now we can very easily check the results here using our resource class, or resource.error. If it's successful, we're going to map our state again to state.copy in this case. Weather info will be the result we got from the API. So result.data, you can see that's a weather info object. Is loading will be false in this case, and the error will also be null. If, however, we got an error, we want to say state is state.copy. The weather info will be null, is loading will be false, and the error will be the error we got from the repository. So result.message in this case. Cool. And that's already everything we need to do to actually handle the success case, like when we get a location. If we don't get a location, we want to go down here to this closing curly bracket and say run. So if that is null, we want to execute this run block. Here we want to say state is state.copy, is loading is false, and the error message is just something we specify here. Couldn't retrieve location, make sure to grant permission and enable GPS, something like that, so that we just know what the error was. And that's already it for the view model. That's all we really need to do here for this simple app. Then the next and the last step, or the next and the last part for this tutorial, is the UI. So now we're going to build our composables that we show on the screen. That will happen in presentation as well. We will actually check our app, how it looks like, and first of all think how we will arrange this. It's a very simple UI in the end, and there won't be any special things to consider here. In the end, we will have a composable for this weather card here, that's how I will call it, so this deep blue thing. Then we will have a simple text here that we will align at the end that just displays that it's today and the time. We'll put that in a column as the first element. We will then put this image as a second element, which we'll get from the state. We'll use the temperature, we'll use the description of the weather type. And here we have another row where we just show this little information about pressure, humidity, and wind speed. And then we will have another composable, which I will call the weather forecast. So for the given day. And there, that's also just a column with this today text. And then we have a lazy row in which we will have these single, hourly composables. I forgot how I called it. We will see. But just a composable for each of these hours. So let's go back and start with our weather card. So weather card, make that a file, composable, call it weather card. And let's think about what we need to know to create this weather card. On the one hand, we need to know our state to be able to show the weather information. We need the background color, so we can keep it flexible from Compose UI graphics. And we want to be able to pass a modifier, which I always recommend to do, that you can pass a modifier to the outermost composable for your composable you're creating. Then we can create our card here, where we can say, okay, we have a background color, which will be our background color. We will have a corner radius, or how is it called? Shape. We make that a rounded corner shape. 10 dp border radius or corner radius. And we say modifier is our modifier we passed, and we apply some padding of 16 dp. Cool. And in that card, we will have a column. We'll say we want to fill the whole width with that column, and also apply some padding here. Pretty clear, I guess, why we do this, so that we just have some spacing here and some spacing here. And we actually only want to show the weather card if the current weather data of our state is actually not null. So we could actually say state weather info current weather data .let and say data or so, and then move that into here. Otherwise we wouldn't show this card at all. And in this column, we will then make use of this weather data. So what comes next? Next, we will actually start with this today text. Then we'll have our image and our temperature and so on. So first of all, a simple text where the text will be equal to today. And here we now need to actually have the time of today basically parsed as a normal time string. So we could say data.time.format, and we can simply specify a pattern here, date time formatter of pattern, and the pattern will be two capital H's and So we will just have this 24-hour format here and minutes. Then I want to make sure that we align this to the end. Alignment.end. So just that it sticks. To the end of the column. So there's a right side. Can I retry this? No. My Android phone always automatically disconnects. I don't know why it does that. However, we also want to assign a color here. I will just hard code these colors here of this app to what I like them to be. I won't use any material theme here, so to not make this too long. So that's already it for the text. Next will be a little spacer with a height of 16 dp. And below that we will have our image for the weather type. So simple image. The painter will be a painter resource. So we want to pick an image from our drawable resources. And the ID of that, we will actually get that from the weather type. So let's do it like this. We say actually data.weather-type.icon resource. That is the corresponding icon that comes from our weather type class, which we have here. So for each weather type, we actually have an icon resource. You can see where I just assigned a specific image for a specific weather type. So we can very easily deal with that on the UI layer. I won't assign any content description here because I'm lazy. And we want to give this a width. So we actually have an image, which I will pick 200 dp here for. And in general, you also want to center this horizontally. So we should assign that parameter here to the column. Horizontal alignment will be center horizontally, unless we specify something like this. Let's have another spacer with a height of 16 dp again. Now what comes next after the image? Next comes the temperature. So we will have a big text where we'll say the text is data.temperature Celsius and then degrees Celsius. Font size will be set to 50 SP and the color white. Then another spacer. Now comes the weather description. So we take a look here. That will be this overcast or whatever type it is, maybe sunny, maybe drizzle or so. So that one we can also get from the weather type here. So for each weather type, we have a description which we want to display. So here's overcast, for example. So we have a text, and the text will be data, weather type, weather description. The font size will be 20 SP here, and the color will also be color white. Then I want to have a little bit more space than usual. Let's say 32 dp. And next, as the last thing for our weather card, will be this section here with these icons and the corresponding values. Whenever you have repeating elements in your UI like this, I will make them composable. In this case, I will call them like, how did I do it? Weather data display. So we just display data of weather, you can say. So let's make that composable. In presentation, weather data display, select file, make it a composable, weather data display. What do we need to know here? Well, we need to know what kind of value we have. So the value will be an integer here. We need to know the unit. So you can see we have HPA, %, kmh. So that will be a string. We want to be able to pass an icon, which is an image vector, a modifier from compose. We want to be able to pass a text style, to be able to change the color here, for example, set it to the default text style by default. And we want to be able to pass an icon tint in form of a color. Is equal to, what's the default one? Let's just say white. And the content will be super simple. We'll just have a row with 2 elements. We make sure we assign our modifier and we assign a vertical alignment to center it vertically. Nothing special. And in that row, we will then just have our icon and our text. So icon image vector will be image vector dot vector resource. The ID will be actually not. We can create this somewhere else. We just pass the image vector here. No content description. We say the tint is our icon tint. And we say the modifier is modifier.size 25 dp. So all the images have the same size. There we go. Next up, we want to have a little bit of space, horizontal space. Let's say 4 dp, not a lot. And then we have our text for our unit. This text will be our value. So first of all, this 30 here, for example, the unit would be percent, and we just concatenate these. Value followed by unit, and the style is our text style. And that's already it for this weather data display, which we can now use in our weather card. So here in a row where we will say modifier is modifier fill max width, and we will say horizontal arrangement will be space around to just kind of, distribute them evenly here. So there's a little bit of space between them, which looks good, I think. And then in here, we will have 3 composables of type weather data display. The value for the first one will be data.pressure. And we need to convert these to integers, I think. Let's say that round to int. The unit will be HPA here. And the icon will be image vector, vector resource, r.drawable. I need to import the right R here. This one from our weather app. Drawable dot IC pressure. The tint should be color white. And we want to assign a text style where we also give this text a white color. So something like that. And then we can take this, copy it 2 more times. This one here will be the humidity. Unit will be percent. This will be IC drop, like a water drop. And here we will use the wind speed. The unit will be kmh. We say IC wind, and that is it for the weather card. We could also already try that out if that looks good. If we go to main activity in here and we get a reference to our view model, private val view model will be a weather view model by view models. We need to also annotate the activity with Android entry point, which we need to be able to inject dependencies in an activity using Hilt, such as our view model. And something we need is we need to request the permissions before we can launch the app, or before we can try it out. So we can say private val permission launcher. So we will use the activity results API for that. Let's actually make this a late init variable. That will be an activity result launcher. of type array of type string. So we can launch this with an array of the permissions we want to request. Then in here, on create, we can say permission launcher is equal to equal to register for activity result. We need to specify a contract here, which is activity result contract. Request multiple permissions, that's what we want to do. And here, as a callback, we get a map for each permission and a Boolean whether we accepted that or not. So that's a callback after we accepted that. We actually don't need that because we checked that in our location tracker. But what we want to do here is after we requested permission, we want to say view model, not that one, view model dot load weather info, because then we have that permission, or we don't have it if we declined, but then we're ready to actually try to fetch the location and tell us if that was successful or not. And then we're going to immediately launch that permission launcher using the array of permissions we want to request, which is on the one hand manifest permission access find location and access course location. Then here in our app, we will just have a big column, which we will make fill the whole screen. So fill max size, and also assign a background color of our dark blue, which we have in our color file. And then in this column as the first element, we will use our weather card. The state, we will get that from the view model. And the background color will also be, no, it will not be dark blue, it will be deep blue, which is even the darker one. And I think that should already be enough to try this out and at least see the weather information in that weather card. So I would say my phone disconnected again. I would say we try this out while I connect to my phone again and see if that works. There we go, build was successful. Here we will see our permission request. Let's say while using the app, then right now we don't see a progress bar, but we see our weather card. So that looks very nice. We see the temperature, we see it's partly cloudy, exactly how it should look like. Of course, that's not done yet. We also need to have our forecast for the given day, but that already looks nice. We also need the progress bar and we need to show the errors, but that's not too much work. So back here in Android Studio, we want to go to presentation and create another composable, which I will call weather forecast. Composable weather forecast, there we go. And all that needs is our state, weather state, and a modifier. Like that. And just as a quick reminder, let me launch the finished app again when I need to reconnect. I have no idea. Do you also have that? That your wireless debugging always automatically disconnects? Like this is now probably like the 10th disconnect during this recording session, which is super annoying. However, now we will build this section here. So just today text and this lazy row, where we'll just display all the times for that given day. So back in here, we will of course need a column. And actually also only display that if we have weather info for the day. So if we have, is it current weather data? No, because current weather data is only for 1 hour of the given day. We want weather data per day. And we want to say get at 0. So that means we refer to today. If we would say get 1, we would refer to tomorrow. So we would show the weather data for tomorrow and so on. So we do have that for a whole week. That's why we have this cool map. And we say .let and take the data here and then put the column in this. Then in this column, you will have a modifier. Modifier dot fill max width and some horizontal padding of 16 dp. Import dp. In this column, we will start off with a simple text for today. The font size will be 20 sp and the color will be color.white. Then we will of course have a little bit of spacing. Let's say that is 16 dp again. And below the spacer we will have our lazy row. So lazy row. And the content will be this. Since our data here is just a list of weather data, we can directly say items, data, and get all the specific weather data objects we have here in this list. And now we need another composable, which basically represents such a single entry here for that weather data. That is just a column with the time, the icon, and the temperature. And I will call that hourly weather display. So we go to presentation again, create that hourly weather display, select file, make it a composable, like that. That will take a weather data object, which we have in our list. It will take a modifier, and it will take a text color, which I will default to white. Cool. And yeah, all in all, we just have a column in here. We assign the modifier to this column. We want to make sure that we center the stuff horizontally, and we want to make sure that the vertical arrangement is space. What did I choose? Space between. Like that. So we just make sure all the stuff is centered here horizontally, and we have equal space between these items. Because we will actually give these items a fixed height, because not all of these icons have the same height. So we want to make sure that all the whole hourly composables are actually the same height. So we need to give them a fixed height. You can see the sun icon is actually a lot higher than the cloud icon. And else we would have different heights for these items, which would look very ugly. And then for the first text, we want to actually have the formatted time. And I will actually use remember here. So formatted time. We could actually also use that for the other one, where I just put it in the code directly. So we will have remember. Make sure to also pass the weather data as a key here. So it will actually refetch that formatted time when the weather data changes. And in here we will say weather data time.format, and we pass our datetime formatter, which we can say of pattern, and we use the same pattern as we had before. So the advantage of using remember here is that this will only be refetched when the weather data actually changes, and not every single time the hourly weather display is just updated. And then in here in the column, we can show this as a text. So text is formatted time. The color is light gray here. And that's it for this text. We will then have our image, which will be the same type of image we would also have used for the main image. So we get that from the weather type. So the painter will be a painter resource, weather data, weather type, icon resource. Content description null again. And we want to give this a size, actually just a width of, let's say, 40 dp. And then we want to have a final text to display the temperature. So we say weather data, temperature Celsius, and then like that. The color here will be white again, and I want to set the font weight to bold. So that will look very similar, actually not too white, we want to set it to text color. So we can change that from the outside, but by default it's white. And then, we just have a column with 3 composables in that, and it will then look, it will then look like this here, like these items. I won't reconnect now. So let's switch back to our weather forecast. And in here for each item, we now want to show this hourly weather display with the corresponding weather data. Which is pretty much just this weather data here. Then for the modifier, we say modifier height, 100 dp, that's how I hardcode it to. And we also want to say some padding, actually horizontal padding, 16 dp. And then it'll look good. the next thing will be, or the last thing actually, will be in our main activity that we make use of this weather forecast. In our column here, below the weather card, let's just have some spacer, 16 dp. We then have our weather forecast with our weather state. And do we need to attach a modifier? Not sure. Let's check here. No. Oh, we actually don't even use this. Let's just pass this here, but it won't change anything. Yeah, I just still want to fill the maximum width here. We could also pass this from the outside. Doesn't matter too much. Let's just go to main activity. That's now it for the whole weather data to display that. But you, of course, also want to be able to display the loading indicator and error messages. So I will handle this the following way. We will have a box that surrounds all this. Modifier fill max size. We will put the column in that box. And below here, we will check if view model state is loading. We want to show a circular progress indicator, which we actually want to center. Let's just center it here in the modifier. Align, center, and we also want to check if the view model state error is not null. In that case, we get the error message here, and we want to show that. We can just check it the way we do here with an additional statement, since these two are mutually exclusive. So loading will never be true and error will never be not null at the same time. Hope that makes sense. So we can do it like this. In here, we'll just display a simple text. Text will be error. The color will be color red. And the text align will be center. And let's also make sure to center it in the box. Like that. I think that should be it. I would say we start this and see how this looks like. There we go. We see our loading indicator. Yeah, looks like it's working. And I will quickly uninstall the app and then reinstall it to decline the permissions to see if the error handling is actually done right. So we click don't allow. And then, yeah, we see couldn't retrieve location. Make sure to grant permission and enable GPS. If we then reopen this, like here, weather app, while using the app, now we accept that. We see the progress indicator again. You can change the color, of course. That looks a little bit ugly right now, but the app is working. Yay! So I really hope you learned something in this video about clean coding, about layered architecture, about clean architecture. And if you actually want to learn about the real clean architecture in a bigger project, in a much bigger project, with use cases, with proper separation of concerns using multiple Gradle modules in Android, then I have a perfect course for that. So if you are interested in that, then it would be really cool if you check the description and check the course. So what we did here really only covers the bare surface of Android architecture, and I can of course dive a lot deeper into that in a real course. That course is like 10 hours, so you will learn a lot more about clean code, about architecture, about how to make applications scale. That'll be definitely interesting for you if you found this video interesting. And that's of course also a perfect way to just help me maintain the channel with all these free videos, of course. So do check it out, first link in the description. And apart from that, I would love to actually know what kind of apps you want me to build in future. They're not too complex, like I won't do a 10-hour course for YouTube. That's just too much for a video. But these, 2-hour courses I think are great here and there. So if you want to see some specific type of app, let me know down below. Thanks for watching. Have an amazing day and rest of the week. See you back in the next video. Bye bye.